afternoon or good morning, everyone, depending on where you are. Welcome along to today's MicroWarehouse webinar on what's new in Windows Server 2016 Hyper-V. This is going to be a fun one because, well, I'll explain a little later. My name is Aidan and I'm the technical sales lead at MicroWarehouse. I'm also a Microsoft Valuable Professional with the Cloud and Data Center Management expertise, specifically Hyper-V. This will be tested today. And I have background in working with Windows Server, System Center, virtualization, and doing a lot of work over the last couple of years on Azure. I blog on my own site on aidanfinn.com, and I'm also the contributing editor on Microsoft Virtualization for the Petri IT knowledge base at petri.com. And you can find my rantings on Twitter at @joe_alway, and I also do some stuff on Facebook on aidanfinn.com. MicroWarehouse is a distributor or a wholesaler to resellers. So if you are working for a Microsoft partner, you can buy stock from MicroWarehouse, like Microsoft licensing, whether it's cloud or volume licensing. You can buy data on, hypergrid, or hyperconvergence infrastructure, or Skykick or whatever, and then sell that on to your customers at a margin. If you are a customer, you can contact your reseller and tell them, hey, I like data on, and there is actually a distributor in the European Union. Contact MicroWarehouse in Dublin and they'll ship it out to us, whether we're in Poland or Ireland or Greece or wherever. If you're in the European Union, we can ship to you. And you can find MicroWarehouse on @MWH Distribution on Twitter. So I mentioned that we distribute data on stuff. So if you're interested in cluster in a box for a small medium branch or small medium business or a branch office in a large enterprise, you can get yourself a nice tidy 2-node cluster. It can be a 2U appliance or a 4U appliance with a small number of disks or a large number of disks running storage spaces. You get all that lovely high performance stuff from tiered storage. If you want to learn more about that, check out our last webinar. We also do JBOD solutions, so if you're interested in the larger stuff where you're getting up to petabytes of storage, we can do that for scale-out file server with high-speed SMP3 connectivity. And coming soon, DataOn have announced that they will be launching their Storage Spaces Direct hardware at Microsoft Ignite at the end of September. And they've already done some public demonstrations where they hit 2.4 million IOPS on an installation. So that's some serious solution that we're talking about there. So if you want that Lego brick approach where you're able to engineer and design this thing at a low cost, have a look at what DataOn are doing and watch out for their announcements at the end of September. We also distribute hypergrid, so if you're interested in a pre-built, rock-solid, high-performance, hyperconverged infrastructure solution for Hyper-V, then hypergrid is one to look at. And they do something interesting, which is hyperconverged infrastructure as a service. So if you actually want to pay for infrastructure as you use it on your own site, this is something new and revolutionary. So Hypergrid do that, and contact ourselves or Hypergrid directly to learn more about that technology, and we can distribute that to resellers in Europe. So what are we going to talk about today? Well, that slide hasn't been updated because I literally finished the slides right before we started. We're going to be talking about Windows Server 2016 Hyper-V, and there's so much to talk about here. Microsoft started talking publicly about this release nearly 2 years ago at TechEd Europe at the end of 2014. And it's had a huge public beta test in the form of 5 technical previews. We're currently on technical preview 5. And we know, because Microsoft have said it, that they will be launching Windows Server 2016 at the Ignite conference in Atlanta at the end of September, the last week of September, the 26th. So soon after that, we should be able to start buying Windows Server 2016 or doing our upgrades with software assurance or even using the free Hyper-V Server 2016. And there's a lot of stuff in there. Some of this stuff they've been working on for a very long time. Some of it from before Windows Server 2012. Some of it's evolutionary. And it's quite a lot of stuff to get to grips with. And I won't be covering everything. Some stuff I'm going to cover in our next webinar. So our next webinar, I'll give you details later, will be on high availability and storage. So we'll talk more about that stuff later on, but I'll give you a couple of bits of information today. Now, I am working with technical previews. And if you've ever attended any launch events before general availability, you know that working with betas is stupid. Doing demonstrations in front of other people is even more stupider. and it doesn't get any more stupider than today, where I'm being the stupidest possible person you can possibly be. Because my demo labs are broke. But I'm going to show you some stuff. There's one demo lab that's seriously broke, and the folks in Redmond were kind enough to give me a video so I can show you some of that stuff in action. But it should all be fixed with general availability at the end of September. So Windows Server 2016, what are the talking points? Well, it's cloud, baby. There's no doubt that this is a cloud platform. It's built so you can deploy clouds, whether it's on your customer sites, in your own site, or you're a hosting company or whatever. And it is very much inspired by Azure. Some of the stuff is directly ported from Azure. And remember, Azure runs Hyper-V. It's the same Hyper-V that we run on-prem. Some of the pieces that we're going to be using in Windows Server 2016 are actually in preview right now in Azure. And we'll talk more about that later. Some of the pieces that you'll do for the larger deployments actually have code ported directly from Azure. You'll see some of that later on. Microsoft wanted to further improve management, so there's a lot of stuff there, whether you're working in small sites, big sites. They definitely worked on that. No, we're still using Hyper-V Manager and Failover Cluster Manager. There isn't a new admin tool. If you want to use System Center, there will be an accompanying System Center 2016 release at the end of September as well. A lot of work done on improving service availability. In the end, Hyper-V is all about providing a service. Virtual machines that run applications or services that the business values. They don't care about the underlying guts and the flashing lights and all that stuff. Our job is to make sure that stuff stays up and running as much as possible and is flexible without having downtime. So there's a lot of work gone into that. And there is no doubt that feedback has shaped this release. So whether it's feedback that you've contributed or voted on publicly at the Windows Server uservoice.com website, or it's stuff that you worked with and you gave feedback on Windows Server 2012, 2012 or you worked with one of the 5 public technical preview releases and gave your feedback via those, you have contributed to this product. A lot of this stuff has been shaped by your feedback. So let's start talking Hyper-V. Some of the new features. So we get connected standby support. So a lot of people who are working with those Windows 8, 8.1 generation devices like Surface Pro 2 or Surface Pro 3 or whatever, and they enabled Hyper-V, they had problems because that device was some clever things with connected standby, where the device was off but not off, and Hyper-V just did not understand that. So the Hyper-V team have improved client Hyper-V so it understands those new power states and doesn't cause problems. That was very publicly talked about by Paul Thurrott on Thurrott.com or Petri.com, and yeah, that's fixed. An interesting feature is discrete device assignments, or DDA, and this is where Hyper-V can connect a virtual machine directly to hardware, so it's no longer virtualizing. So you might be familiar with RemoteFX, where we could virtualize graphics adapters in a Hyper-V host. 2016, we can do something that's currently in preview on Azure. With the N-series virtual machines, where we provide virtual machines direct connectivity to PCI devices like a graphics card. So we can start giving a virtual machine direct access to the cores and memory on a graphics card, which means we get hardware level performance, not virtualization level performance. We have this concept of VM versioning. This isn't actually something new. This is something that was hidden. When we deploy a virtual machine, it has a version. So when we deployed a virtual machine on Hyper-V 2008, it had a particular version. 2008 or 2, a higher version. 2012, another version. 2012 or 2, another version. 2016, we'll have another version again. If you're running Hyper-V on Windows 10, you'll actually see this, that your virtual machines, if they have the current version, they are version 8. Microsoft are making this version public because, well, we can expect, and we know, that going forward, Windows Server 2016 is going to get probably 2, maybe 3 cumulative updates per year adding functionality. If a virtual machine has down-level functionality version from the host, it won't be able to avail of that functionality that's available on the host. So we'll be able to upgrade that version of the virtual machine. That'll help us control VM versioning as we move forward. And I'll explain why that might be a little bit important later on towards the end of the presentation. If you've toyed around with the files of a virtual machine, you'll be familiar with the fact that there's things like virtual hard disks, VHD or VHDX files, but there's also the metadata of the virtual machine. So there was a XML file which described the spec of the virtual machine, a text-based file, which you could edit. You're not supposed to. It was completely unsupported. You were supposed to go through the management interfaces to edit that file. And Microsoft have changed that format to a VMCX file. It's a binary file which you cannot edit directly. Now, you might say, well, that's going to be a problem for me. It shouldn't be, because you're supposed to use the tools that are provided, whether it's PowerShell, WMI, Hyper-V Manager, Failover Cluster Manager, System Center, whatever. You're supposed to use those tools to manage the configuration of the virtual machine. Microsoft have found that in very large deployments, switching to binary is actually improving the performance of the host and the virtual machine. So that's the primary reason they're doing that. And they are working with big-scale customers. They need to be able to give those people performance. We've also seen the .bin and .vsv files being converted to a VMRS file, so just a single file, a runtime state file for that virtual machine. Okay, let me talk about something new called Nano. So Nano was one of the headline features in Windows Server 2016. And Nano is a new installation option of Windows Server, and you won't be able to get that from the DVD. Instead, you'll actually deploy this using some special tools. Now, I suspect we haven't seen all the tools yet. I think that Microsoft will be showing us a few more tools down the road. But we have a tool that is on the media that we can use. Let me just find the right environment so I can actually show this to you. It's a demo. So what I've done is I've copied the installation media of Windows Server 2016 onto the C drive of this management machine. And from that, I have copied a folder called Nano Server. Which is there, and in that Nano Server folder we have the bits to make a new installation of Windows Server. This is a tiny, tiny footprint installation. So in 2008 we saw that we now had the option to do a full install or a core install, and core install stripped away the GUI and left us with a command prompt and PowerShell. Nano Server goes one step further. There is no UI. Well, there is a teeny tiny little thing for troubleshooting, but you will not do any local administration on a Nano Server. It will all be done remotely using PowerShell, Remote Server Administration Toolkit, a new user interface in Azure that you can connect to your on-prem Nano servers, or System Center. And we can create this right now using a PowerShell script. So I'm going to say, let's create a new virtual machine called test.mwh, and I want a particular password, and I'm pre-provisioning my domain join. So if I go to Active Directory, refresh, there is my computer account, and it has created a djoin file that will be used to join my machine to a domain. Meanwhile, this command has run, and it is now building a virtual hard disk file. I believe it is that one there. So a virtual hard disk file is being built right now. And after a minute or two, I will have a new installation of Windows Server 2016 in a Nano format. Now you might look at that and think, well, we're only at, what, 430 megs. It's going to take, geez, how long is it going to take to actually build that thing? Because Windows Server is like 12 gigs in size, right? Yeah, not necessarily. So let's have a look at an existing machine. Have a look at the virtual hard disk. 620 megs. Is that right? That can't be right. 606 megs. That's a full Windows Server running. Now, how small is this thing? Well, if we look at the properties of this machine, it is currently using 161 megs of RAM. We've assigned 190 megs. Previously, to get down to those sort of levels, I had to deploy Linux without a user interface. Just command prompt. And now I have a Nano Server running nice and small. Now, Nano Server is going to support a bunch of different roles. The key ones there is it's going to be able to be used for SMP3 storage, and it can be used for Hyper-V. So you can run a Hyper-V host that is tiny. Now, to be quite honest, I'm not sold on that concept personally. I see Nano being more interesting in application servers, because a Hyper-V host, sure, I'll save a few megs of RAM or a gig or so of RAM, but a gig out of 256 gigs is not that big a deal. The small disk isn't that big of a deal because I'm going to have to buy 300 gig disks for my physical hosts anyway, because I can't install this onto USB. It's not supported, so or SD either. So I'm stuck with having to install this the normal old-fashioned way. or deploy the virtual hard disk the old-fashioned way onto a physical disk and boot from that virtual hard disk. So I don't see the savings really for Hyper-V, but I see it being more important for the guests. This thing's going to require a lot fewer patches, so there's a lot less stress on WSUS, on the network, on the hard disk system during patch windows. It's going to have a much smaller attack surface, and it's going to force people into doing proper administration the way they're supposed to be, which is remotely. You're not supposed to be managing servers on servers. And as you can see, the resource utilization is small, and the savings from maybe 20, 100, 1,000 machines running this form of installation are going to be much better than, say, on the Hyper-V hosts themselves. So I think this is going to be a rather interesting one to watch and to see how it develops in the future. So that's Nano Server, and it looks like our virtual hard disk is built. So let's go and have a look, and there it is. Now I could create a new virtual machine without a virtual hard disk, a Generation 2 virtual machine, and doing secure boot, and I can attach that virtual hard disk, and it will actually boot up really, really quickly. And what will it look like? Well, let's connect. There is the interface. We'll sign in, if I can get my password right. And that's it. I can do some basic configuration of the network. I can have a look at the firewall rules and enable, disable them, and I can reset WinRM. I've got to do everything else remotely, and that's Nano Server. Next one. This is going to be good news for a lot of people. Nested virtualization, the ability to run Hyper-V inside of Hyper-V. Now, previously there was tricks to make it install, but we couldn't actually launch a nested virtual machine. We couldn't get it to run. We could deploy it, but we couldn't get it to run. And we can do this now on Windows 10 and Windows Server 2016. Windows 10, make sure it's running the anniversary update, and virtual machines are on version 8. Windows Server 2016, make sure you're on TP5, your virtual machines are running version 7.1. 2016 hasn't caught up with Windows 10 yet. Why would I want to do nested virtualization? Why would I want to run Hyper-V inside of a VM? Well, if you're a hands-on techie type of person, you've probably tried to set up a training lab, a demo lab, or whatever, and you've wanted to do clustering, and you just haven't had the hardware. You haven't had a set of servers that you could deploy. Now with a decent desktop or laptop with 32 gig of RAM or whatever, you can set up a very interesting demo lab or a training lab where you can test out most of the stuff that you can do with Windows Server 2016. And realistically, if you want to do all the stuff, you're going to be looking at maybe 192 gig of RAM, 256 gig of RAM, and that's some of the high-end stuff for larger enterprises. This is a very cool piece of technology. I use it myself. I have it running on another laptop. The laptop I'm using today is actually my brand new Surface Book. Gorgeous machine. Well done, Microsoft, because it really is a premium device now after the spring updates. But nested virtualization, big ask for specifically by techies, IT pros, developers, consultants who wanted the ability to do a lot on one machine or two machines. They just didn't have the budget for lots more. Should also make a huge impact on technical training going forward. I'm looking forward to deploying this myself in our new training lab that we're building here in MicroWarehouse. Where I suspect Microsoft, or we've been asking for this for years. We've been asking for this since 2008. And Microsoft said, yeah, we'd love to, but we don't really have a business reason to do it. We have other things that are higher priority. And it always got pushed down the stack because they stack rank the things that they can develop in a certain time frame. What I think pushed it up the stack into, yes, we need to develop this, is something called Hyper-V containers, which is something that's going to be used in Microsoft Azure. And we'll talk a little bit more about containers later on. Now there's a few things to know. You're going to need some modern hardware here. So first off, Windows Server 2016 Hyper-V is going to require that you have second level address translation. So Intel call that EPT, I think AMD call it MPT. So if you've got an Halem or later processor, which to be quite honest is fairly old at this point, you're good. If you're on a really old machine, you're not going to be able to run 2016 Hyper-V. Now to do nested virtualization, you will need an Intel processor. Sorry if you're using AMD. You'll need Intel VTX and EPT in that processor. You need Windows 8 Anniversary Update or Windows Server 2016. vSphere might work, but it's unsupported. I have seen some stuff online where people are saying that they got vSphere running inside of a Hyper-V host. I don't know how valid or true that was, but it will be completely unsupported, I suspect. Device guard, a new security feature, must be disabled on the host. So if you're running Windows 10 Enterprise Edition, make sure device guard is disabled. And if you're using virtualization-based security, so there's a number of things that means, that must be disabled as well. Now the virtual host, this is the virtual machine that's going to be a host, sort of the second tier. We still don't have a language yet to describe the various layers within this. Because one of the interesting things about nested virtualization is I can create a physical host with a VM and take that first level VM and turn it into a host. And inside that first level VM I can create another VM, the second level VM. And I can convert that into a host. And I can go infinitely like that. What was the name of that movie, John? The Dream Within a Dream thing? Oh, I can't think of it now. But we can do that with virtualization. Yeah. There's a couple of requirements for the virtual machine. It's going to be a virtual host. Inception. There we go. Inception for virtual machines. So we need to enable MAC spoofing on any NIC that's going to be used for the virtual switch, because that virtual machine is actually going to have, or that NIC is now going to have multiple MACs going through it, and Hyper-V would normally not like that. Dynamic memory must be disabled on the virtual host. We can use dynamic memory within the VMs within the virtual host, as long as they're not going to be virtual hosts as well. Runtime memory resizing cannot be used. We cannot live migrate the virtual host, but we can live migrate VMs within the virtual host. Getting funky, isn't it? No checkpoints of the virtual host, but we can do checkpoints inside the virtual host. And you must be running the latest VM version. So, quick demo. There's not much to show, to be quite honest, because it is rather simple stuff. We'll create a VM, and I have one already. Go to settings, make sure dynamic memory is disabled, go to the network adapter, that's going to be used for the virtual switch, make sure MAC spoofing is enabled, so we can support multiple MACs going through that NIC down to the VM bus in the physical host. Then, when the VM is not running, we will go set VM processor minus VM name demo VHV1 minus expose virtualization extensions true. You run that. In technical preview, we're told it's completely unsupported, yada, yada, yada. And then you start up your new machine and you enable the Hyper-V role. And now you have yourself a second level Hyper-V host. If I connect into this and sign in, and you can see I actually have a virtual machine running within a virtual machine. Funky. Funky called Medina. And more 1980s references to come later. So security, a lot of work has been done on security. So as I said, 2016, very much a cloud foundation, and Microsoft want people to use this in public and private clouds and hybrid cloud solutions as well. The hypervisor itself has been hardened. A lot of work has been done by the core hypervisor team, or the kernel hypervisor team. Host resource protection is a new feature from Azure. When you're running a cloud environment, very often as an administrator, you have no idea what the tenants are actually doing inside of those virtual machines. And sometimes a virtual machine will be compromised, either by a rogue tenant, or the tenant has some bad code and maybe someone actually hacks that code and gets into that virtual machine and starts attacking the host to try break out, or tries to attack other virtual machines on that host. Now Hyper-V is fairly secure. Breakout attacks are, well, I think there might have been one vulnerability found, but Microsoft patched that up pretty quickly. We don't have really successful breakout attacks happening on Hyper-V. What a tenant can do is try to do a DDoS attack on the host. And Azure, and now Windows Server 2016, can detect that and start starving that virtual machine that's performing the DDoS attack of resources. So it's not actually able to perform the DDoS attack against the host. So that's a nice feature. Completely configurable, controllable as well. If you're running Linux Generation 2 virtual machines, you can enable Secure Boot. and this protects the kernel against things like rootkits. Or not the kernel, the bootloader. So you can have a more secure Linux installation the same way as we can Windows at this point. If you're running a true cloud, so you're running a very large enterprise or you're running a hosting solution, then this is going to be interesting, these next couple of slides. The first piece is guarded fabric. When I started working in the hosting industry and working with virtualization, I was asked by a security expert, what's to stop a rogue operator, the least paid person in your company, from taking the files of my virtual machine, bringing them home, mounting the virtual disks, and stealing my data? And I was like, security cameras? Because there's really not much else. Maybe the security guard might see them bringing around some USB disks or something. And that was a problem. Guarded fabric protects us against that. It basically controls what hosts that virtual machine will boot on. It's a new attestation service called the Host Guardian service, which is deployed into a dedicated Active Directory domain, a small domain, a couple of machines. And you can deploy this using System Center from a template. And there's plenty of documentation on how to deploy this solution as well at the moment. There's two models. There's the admin trusted model, which is maybe for internal clouds where you do trust the small number of human people, or if you're doing a proof of concept and you have limited access to new hardware. Now we have something called a TPM trusted model, and this is the secure one. If you're running a true public cloud, this is the solution you'll want to be interested in. TPM trusted, well, it's using TPM chips. So the hosts will require, the Hyper-V hosts will require TPM 2.0, which is still very new in server hardware. In fact, I'm not aware of, at the moment, any server hardware that has TPM 2 unless it's very, very new. And also must have UEFI 2.3.1 with Secure Boot enabled. Every time I say UEFI, I want to say WEFI. The Host Guardian service, which is running in that small little Active Directory domain, is going to require a HSM appliance to store certificates. Basically, the way this works is when a virtual machine tries to boot up on a host, it's going to apply, the host is going to apply for a certificate to be allowed to boot up that virtual machine. It will go to the Host Guardian service and be issued a certificate to say hey, you can actually launch that virtual machine. Without that certificate, you can't launch it. And that's how that process works. We also have shielded virtual machines. So this is for the tenants to say who can actually get into my virtual machine. So there's a couple of different things here going on. First is TPM, virtual TPM within the virtual machine. Now this does not require physical TPM on the host. It is a virtual TPM appliance or device. It means the tenant can enable BitLocker in their virtual machines. The tenant will be responsible for the BitLocker recovery keys, not the hosting provider, because the hosting provider has no access to the virtual machines. And we have levels of access that we can allow. We can completely block out admins, or we can only allow a certain amount of access in. And this includes things like using the Connect window from Hyper-V Manager or Failover Cluster Manager. It includes things like KVM or the other integration components on the hosts as well. So we can really tie down what people are able to do. This is going to be interesting, I think, going forward to see if Microsoft will do this inside of Azure, because it will deal with a lot of the trust issues that people have with working with American cloud services. Another very cloudy concept, this is more aimed at developers, but it's something that we will be deploying on behalf of developers or managing on behalf of developers, is containers. Now you may have heard the phrase Docker quite a bit, and Docker is involved in this. They are a management solution for this that Microsoft actually is working very closely with. And if you are using Windows Server 2016 containers, you are going to be working with Docker. If you look on the Microsoft.com documentation for containers, you will see it's all Docker, 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 Docker. It's a new way to deploy applications or services in the cloud or even on-prem. And it's not doing machine virtualization. It's doing operating system virtualization. So machine virtualization, we still have one operating system per machine and typically only one application on that operating system. Application or operating system virtualization is where we say, okay, I'm going to create these little containers or bubbles that allow me to have multiple independent applications that are isolated from each other on a runtime basis on a single operating system. And the cool thing about this is it's all based on a repository solution. So I deploy a container that has a link to an image in a repository, and it only stores changes within the container. That means I can deploy an end-tier application in seconds, literally seconds, instead of deploying a machine. Even with the most advanced template-based solution using System Center on Hyper-V, it's still time-consuming to deploy a new application using virtual machines. But with containers, you're talking about seconds. And you're able to create layers of images. So I can have an image for Windows Server, I can have an image for IIS, an image for WordPress, an image for MySQL, and I can link these all together to create a WordPress deployment. And reuse the individual layers for different types of deployments. There are two ways we'll be able to deploy containers. The first is Windows Server containers, where I can deploy a physical machine or even a Windows Server Hyper-V virtual machine running Windows Server, and I can run containers in there. Now, I said they're isolated. They are from a dependency point of view, but they're not securely isolated from each other. So this is where Hyper-V containers comes in, and this is something that probably was developed specifically for Azure, and we're getting a benefit of. Hyper-V containers gives us secure isolation between individual containers. It runs a tiny, tiny version. The Hyper-V container runs a very tiny version of the operating system image, and then has the same type of container as we get in Windows Server containers. They're portable between the two. And it uses the hypervisor containerization to securely isolate one container from another. We have a number of operational improvements. Some of these were hot asks and a bit of a pun there, because one of them is hot add remove of memory and virtual NICs. So if you need to add memory to a static memory virtual machine, you can do that. And you can remove the memory as well, as long as it's not being used. You can add NICs and remove NICs without having to shut down that virtual machine. So we're keeping uptime going. No, there is no hot add and remove of processors at this time. That's a very tricky one to actually implement. Though Microsoft have heard that feedback, I'd say it's something that they would like to do. Hyper-V Manager has some improvements in there, so you can connect to hosts using alternative credentials. It uses a new protocol for connecting the hosts. You'll see some stuff in the UI about providing you more information about demands of a virtual machine. You saw a little bit of that earlier when I showed you memory utilization of a virtual machine. That's there for static memory virtual machines as well, not just dynamic memory virtual machines. The integration components or integration services, these are the drivers within Linux and Windows that make a virtual machine aware that it is a Hyper-V VM and it's able to access all the services and features and run with good performance. In the past for Windows, we had to deploy these by hand or use some sort of automation solution like System Center Configuration Manager. Microsoft, starting with Windows Server 2016, are going to be deploying these using Windows Update. That was a huge ask for the last, I don't know how many years, and we're finally getting that going with 2016 forward. I mentioned VM version earlier on, and we're also getting something called resilient change tracking or RCT. When you're backing up Hyper-V virtual machines, your backup solution without some sort of change tracking can't do incremental backups of the virtual machines. It can only do full backups. Change tracking, something that a number of the backup vendors have implemented themselves using a kernel level filter driver, but tracks the changes at the block level of your virtual hard disks. So it knows what it has to actually back up to do an incremental backup. It only backs up those blocks that have changed. The problem that Microsoft found was backup is probably the number one, number two source of support calls for Hyper-V. It's one of these red flag type things, constantly at the top of the list. And Microsoft really wanted to fix this. And one of the problems they saw with backup was third-party kernel filter drivers. Sometimes they weren't well written and they caused a lot of problems. So Microsoft wanted to remove those, and their approach was, well, we're going to do resilient change tracking ourselves. So the backup vendors can actually leverage this. And they started reaching out to those backup vendors 2 years ago. So they shouldn't be surprised that this has actually been introduced. So it stores the change blocks in two ways. First is the most granular one, which is in RAM on the host that the virtual machine is running on. But it also stores it on disk because the host might crash, the virtual machine might move around, so that change tracking database for that virtual machine will move around with that virtual machine. Okay, next thing I want to talk about is PowerShell Direct. So PowerShell Direct is the ability to start doing remote administration using PowerShell even if you don't have any network connectivity. So let's see if I can find my demo. Nope. Yeah, I have to get onto one of the hosts. There we go. And grand. So run PowerShell. So it might be that a virtual machine has lost network connectivity because of some fault. It might be that you've deliberately isolated a virtual machine. It could be a tenant in a public cloud. It could be a DMZ or something like that. So here I have a virtual machine that is no longer responding to pings. And I don't have the ability to remote desktop onto this machine, and my customer has said, can you help me? I need to get this machine back online, and I really don't know what's wrong. So I've done some basic troubleshooting. I can't ping the virtual machine. I have checked the settings of the virtual machine, make sure somebody hasn't done something silly. The virtual machine is running, and I can see that it is connected to a Hyper-V switch, but the switch port is reporting that it has lost communication with the virtual machine's NIC. So something's wrong, and it looks like that something wrong is in the guest OS. So I'm going to check inside the virtual machine. I've no network connectivity, but I'm able to do it using invoke command minus VM name instead of computer name. Now, if I was doing this myself manually, I could do enter PS session minus VM name, so I could have an interactive session rather than just running one-off commands with invoke command. So I can see that the NIC has an unknown state, so it's probably been disabled. So what I'm going to do is I'm going to enable the network adapter inside the virtual machine without network connectivity. Now I can check the status, and I can see that the NIC is connected and is now responding to pings. Customer's happy, my boss is happy, I'm happy. So that's a quick look at PowerShell Direct. Next one, production checkpoints. Another cool one. Who believes checkpoints are good things for production? And the official status of that is you're a moron. Checkpoints were not supposed to be used for production. Never supposed to be used for production. And for those of you who think Hyper-V snapshots / checkpoints were good for backup, please quit. Go pick some vegetables. You might be safer. The world certainly will be. We can create a checkpoint for a virtual machine, and the way a checkpoint is being done has changed in 2016 by default. It's doing something called a production checkpoint. What it's actually doing is using the snapshot or the checkpoint mechanism that's used by backups. So it is kind of creating a backup, but it's still not a backup. Please use a backup tool if you want to do a backup. And plenty of them out there. If you want to use DPM, you want to use Veeam, if you want to use Altaro, if you want to use Azure Backup Server, plenty of different tools out there that will do fantastic backups of your virtual machines, ranging from free to very expensive. Checkpoints are not backups. However, they are a means to be able to make a change to a machine, and if it doesn't work out, I can roll it back. Or if I'm doing test and dev type stuff where I can have multiple different time snapshots of my machine and I can jump between different times, it's good for that. And Microsoft realized in this world of DevOps that they needed to have this sort of thing for production. And that's why they're now using the backup technology of Windows Server 2016 to create the checkpoint, which means the recovery process is a little different. So if I connect to my machine, and I now do an apply of my checkpoint, it's not going to restore that machine back to exactly how it was. What it's actually doing is the exact same as restoring a backup. It's actually going to boot up the machine from that point in time. Now what we get here is consistency. This is the important thing. We get file system and application levels of consistency. So if I was running SQL Server in here, SQL Server would realize, oh, I've been restored from a backup. I need to do this, this, and this. Rather than just being, oh, things are back to normal, back where they were 2 days ago, where something bad could happen, and unfortunately I have seen that bad happen. Now you'll see it did not start up automatically, one of the little gotcha things that keeps tripping me up. So I have to power up that machine myself, and that's what's happening. It's not returning it back exactly as it was when we took the checkpoint, but it is consistent. That's the important thing. We we get file system consistency, application layer consistency, which means production checkpoints are supported in production, hence the name production checkpoints. A lot of improvements in storage. Resilient file system or REFS was introduced a couple of versions ago in Windows Server, and now in 2016 we see REFS hit theme big time. Now it's going to be the file system of choice for running Hyper-V. So REFS, if you're not familiar with it, is a new file system that's there side by side with NTFS, and it's for data volumes. It's not for operating system volumes. Lots of different things in there and how it deals with data. It deals with data using metadata and then the data. A lot of stuff about logging and fault tolerance and stuff like that. We don't have to use check disk because, well, we don't have to use check disk. So it's a very cool system. Part of what we've got in 2016 is faster VHDX operations. So if you want to create a fixed VHDX file, it's actually a metadata operation. So if I want to create a 1 gig fixed VHDX file, it'll take a second. If I want to create a 100 gig fixed VHDX file, it'll take a second. If I want to create a 1 terabyte fixed VHDX file, it'll take a second. Whereas if we were doing it the old days on NTFS, 100 gigs, go for lunch. Come back, maybe it'll be done. This affects other things like checkpoint merge, which impacts things like backup and production checkpoints, which are being used by the DevOps people. Now, applying and merging checkpoints don't impact the storage system as much. It's a metadata operation. Instead of moving blocks around, it actually updates the metadata to say, stop using those blocks, use these blocks instead. So it's much more efficient. We have a new shared VHDX format. Shared VHDX was given to us in 2012 or 2, but there was tons of restrictions. We have a new format called VHDS, or a virtual hard disk set. It's actually made up of 2 files. There's a metadata file and a data file. And from this, we are now getting support for host-based backup, Hyper-V replica, and online resizing of the shared virtual hard disk. This means we can start really using this type of shared virtual disk for guest clusters. So if I want to create a Hyper-V cluster, storage cluster, SQL cluster, or whatever, without having to use iSCSI or virtual fiber channel, I can now do this on a completely virtual layer. We're also getting storage replica. I'm not going to talk too much about that today. We'll cover that next month. Storage replica is block-based asynchronous or synchronous replication that is completely supported by Hyper-V and failover clustering. Lots of cool things we can do with this. It's only in the data center edition, unfortunately. So you'll notice there are going to be a few things or a few changes in licensing with 2016. So there are differences between standard and data center for the first time in a while, and this is one of them. This is a very cool feature. If you want to create a 2-node cluster using internal disk, you can do that with storage replica. If you want to replicate one cluster to another in 2 different sites, you can do that. If you want to stretch a cluster with the same or different types of storage, you can do that. Very cool stuff with storage replica. Next thing I want to show you is storage QoS. If I can remember where I put that lab. I think I put it on this host. Yep, I did. And I didn't reset the demo, so this should be interesting. So I've got a virtual machine that is idle at the moment, and it is stored on CSV, and I'm going to run this script and set up the demo. And what I'm going to do is, inside the virtual machine, I'm going to run a stress test. And we can see that virtual machine is now stressing the disk. It is hitting, about 100,000 IOPS, we'll say. What I'm going to do is create a QoS policy. So this is where I can say I want to supply minimum amount or maximum amount of IOPS for a virtual hard disk, virtual machine, or a customer. It's a new distributed QoS system that completely replaces the old one that we had in the past. That policy has now been applied to my virtual machine, so my virtual machine is being limited to 200 IOPS. So where it was hitting 100,000 IOPS, it is now hitting 200 IOPS. Now we'll remove the policy and we'll see backup, and we're hitting 100,000 IOPS again, which is kind of cool. So that is storage QoS. We can do that with block-based storage, so if you're using SAN with direct CSV, or if you're using a scale-out file server, we can do this as well. Now speaking of scale-out file server, Let's talk about storage spaces direct. Again, I'm going to cover this more next month. This is a new way of doing storage spaces. Right now, if I'm doing storage spaces for a scale-out file server, what I typically have is a set of Hyper-V hosts that connect to a number of nodes in a cluster of file servers, and those file servers have shared JBODs behind them. In storage spaces direct, we're removing the JBOD. Well, optionally removing it because we can only use it for extendability. Instead, if you look at the bottom of that image, you'll see that the storage spaces nodes are using internal disk, and they're replicating that data across each other. So each node is basically a Lego block in the storage system. One of the improvements that they've done with this is we don't have to use SAS anymore. We can actually start using SATA. This makes flash storage much more affordable. Another improvement is that they're introducing support for NVMe storage. This is ultra-fast PCI speed flash storage. So very interesting things there. It'll be interesting to see where they go with the next generation of flash storage, which apparently runs at RAM speeds or near RAM speeds. I expect we'll see support for that down the road. It's a very interesting solution. Tiering, it's multi-resilient tiering. So we've got, if we use NVMe, we can use that as read and write cache, so it's persistent. And then beneath that, we could have SSD and HDD together with mixed mirror and parity. So this is something where we can really stress the various different features of not just the levels of disk fault tolerance, but also the speeds and capacities and economies of scales of those disks as well. A next step forward from storage spaces direct being used as a scale-out file server is to actually flatten the infrastructure even more. Instead of having Hyper-V hosts and storage nodes, let's flatten the entire thing completely and do hyper-converged infrastructure, where the Hyper-V host actually has the storage and it's replicated to the other nodes in the cluster. So we can completely get away from SAN altogether and shared storage type systems sitting on another tier in the network and just flatten the entire deployment. So it's a Lego block. If I need to scale out my deployment, I just put in another server in the cluster. It's an interesting solution. I'm kind of looking forward to playing with this. It does require some cool hardware, unfortunately, which I don't have at this point. But speaking of hardware, DataOn will be supporting this. They will have 1U and 2U appliances, which they will be announcing at the Ignite conference, and we will be able to distribute to resellers for that in Europe. So that'll keep the boss happy. Networking side of things. If you've worked in Azure, you have probably done things like deploying firewalling and load balancing without actually deploying an appliance. It's stuff that's just there. You just turn it on and start using it. This is coming into Hyper-V as well, but I'll talk more about that. We're also getting a new type of software-defined encapsulation. So software-defined networking in 2012 and 2012 used the NVGRE protocol. That continues, but the rest of the world went with VXLAN. So Microsoft is jumping onto that bandwagon too, so they're adding support for VXLAN. And to take advantage of all this stuff, we have a new thing called Network Controller, a centralized way of managing this distributed network. So we have distributed firewalling and load balancing and all that stuff within the fabric itself, so we don't have to deploy those appliances. And the Network Controller manages all that from a central point. It is a Windows Server role. It is only in the Data Center Edition. And it is code that is ported from Azure. So if you want to be able to deploy networking the way that Azure does, you will actually use the Network Controller role in the Data Center Edition. Now let's get back to basics, fundamental stuff, the virtual switch. In the past, if you wanted to do a virtual switch, you typically created a NIC team which aggregated 2 or more NICs, and then created a virtual switch which connected to the NIC team. Switch embedded teaming, or set switching, replaces that optionally. We can still do it the old way, but if we want, we can do switch embedded teaming, where we create a switch and say, instead of this one NIC that you're going to connect to, you're actually going to connect to these couple of NICs. And now we have simplified the deployment. The teaming is actually being done in the switch. And it has most of what you would expect in teaming in Windows Server 2012, or actually 2012 or 2. That functionality mostly is there in switch embedded teaming. The default configuration is the best one. To be quite honest, I've been working with it now for a while, and it's rock solid. It just works, and it's simple to deploy, which I like. It's a one-liner in PowerShell, and a very simple one-liner. Another improvement, if you are working with SMP3 storage, so scale-out file servers, there's a good chance that you want to use Remote Direct Memory Access, or RDMA, or SMP Direct, as it's known in the Microsoft world, which is kind of like what some of the stuff that Fibre Channel tries to do, but it does it better. So we get low latency, low CPU impact storage traffic. But Microsoft uses it for more than just storage. They also use it for live migration and other stuff. In the past, you needed a physical NIC and direct access to a physical NIC to do that. The host can now do that using a virtual NIC that's connected to the switch. And obviously we'll use DCB to control that traffic as well, so we have a smooth flow of traffic overall. We don't have support for it in the virtual machine yet, but we do have support for the Management OS virtual NICs. So that's going to greatly simplify host deployments where we're using SMP3. Basically, you'll just need 2 NICs, so a nice good ConnectX-4, ConnectX-5 NIC from the likes of Mellanox or something. Now, anyone spot something strange about this Azure portal? If you look at the URL, you'll notice that it doesn't say portal.azure.com. It says portal.azurestack.local. That's because it's not Azure. Well, it sort of is. It's Azure Stack. Microsoft are bringing Azure on-prem. So you'll be able to deploy real Azure, not Windows Azure Pack, because Windows Azure Pack tries to look like the old Azure Management Portal, but it's not really. It's System Center with a skin on top of it. Azure Stack is Azure. It has blob storage. It's using the network controller to do all the network virtualization stuff that you get in Azure. It's using the same PowerShell commandlets. It's using JSON templates. If you are working with CSP, it's basically the same thing there. If you're working with the other channels of Azure, it's ARM. It doesn't do SM or ASM, the older version of Azure. It will be available mid-2017. Microsoft have stated that publicly now. And it will only be available on pre-packaged OEM hardware solutions. Microsoft, I've been thinking about this, the positives and negatives. Negative-wise, it reduces availability a little bit. Possibly the OEMs might screw us on pricing. Good news is, well, it means the thing will be packaged. It'll be tested, which means Microsoft can guarantee a level of quality on the deployment. This is an important thing for them. They're worried about people getting this Azure on-prem and it not being good. They want it to be superb every single time. And on the good news on the pricing, Data-On are planning to be one of those OEMs. And Data-On love being cheaper than the other guys. So watch out for news on that next year. More stuff on the high availability side, we get compute resiliency. So this is a new way of dealing with transient failures within a Hyper-V cluster. Sometimes NICs have a problem. Sometimes somebody pulls out a cable they shouldn't. Maybe there's a glitch of some kind. And if we said, okay, there's a timeout in the heartbeat and the other nodes in the cluster are worried about the other guy and they're going to do a failover, well, all the virtual machines that are on that perceived failed node will fail over and have to boot up from cold and start their services. That could be several minutes before everything's back up and running. Meanwhile, that node's come back online because the operator put the cable back in. Compute resiliency says, let's just wait a little bit longer. We'll isolate that host a little bit. We won't put anything on there, but we'll leave the virtual machines running. Because if it comes back online, those virtual machines will just reconnect to the network and everyone will be happy. Now you can tune that sort of thing as well using some PowerShell, but it also accounts for the fact that there might be flapping. So if we get, I believe it's 3 of those transient failures within an hour, that node will be quarantined and it'll live migrate the virtual machines onto the other nodes in the cluster. So operators can come in, figure out what's going on and fix that particular host. Maybe they'll just rebuild it. It might be the quickest way of dealing with it. We get ordered started virtual machines. Now this isn't the old priority system, which was kind of misused for ordering. It was really meant to be used for a different sort of thing in the failover scenario. We get the ability to start defining sets of machines and say that this set must be started before this set. We can define within a set what actually is a success. So if we have 3 domain controllers, maybe if 2 of those domain controllers are up, the domain's active, let's move on to the next set and we'll wait for the other domain controller to come online. So it's a cool new feature that's there, and it was, I think, in technical preview 4 that was added. We also get node fairness, load balancing within the cluster based on memory and CPU, I think. And there's 3 levels of aggression that we can set in that high, medium, and low. So Microsoft are thinking that the high aggression system might be the one for people to start with, but they're leaving it on low by default, so you have that choice to opt in and opt out. So it'll load balance virtual machines using live migration across your cluster. Okay, storage resiliency. I'm going to thank Shubhashish, sorry if I mispronounced your name wrong, for giving me this video. I tried getting this demo up and running myself yesterday, and I had problems. So the idea here is sometimes our storage system has a glitch. And if our storage system has a glitch, every virtual machine that's on that storage system will panic, crash, and die. And we'll have to get our storage system back up and running. It might come back by itself after a couple of seconds. And then we have to start up all our virtual machines again. And that can be a major pain on the backside, especially if you are in that service provider type world. It's better to have, a brief pause in everything while the storage system comes back, and then we can say, okay, what's wrong with the damn storage system? Let's fix the thing. So what Microsoft has done is they've built in a tolerance, so to speak, for a storage system having a problem. So in this demonstration, there's a bunch of virtual machines on a Hyper-V cluster, and they're stored on a Microsoft iSCSI target. And the target is being disabled, which means the SAN is disappearing. And now the virtual machines are running away, and if they're not doing any disk activity, nothing's going to happen. But eventually they'll do some disk activity, paging, database queries, whatever. And those IOPS, it's going to cause the virtual machines panic and crash normally. But what you're going to see instead is the storage has now gone offline. It's been perceived by the cluster. And if we see the CPU level on the virtual machines has plummeted, so something's going on. And we know because the storage has been pulled. And if we jump forward, we will see the virtual machines which are in a running state are actually going to switch not to a critical stop state. They're going to switch to a paused state. So the virtual machines have been paused. Hyper-V has seen that an IOP has failed and the storage is gone, so it's paused the virtual machines. And now the storage will come back. And when the storage comes back, the virtual machines, you'll have to be quick here because the video ends rather abruptly, go back into a running state automatically. So that's saving a lot of administrative hassle by dealing with that glitch. Now all this stuff sounds fantastic. I've got myself 2012 or 2 cluster. I love the sound of all this stuff. It's going to be a nightmare to migrate my cluster to a 2016 cluster, right? Wrong. Big ask of Microsoft was, hey guys, we know you're going to give us upgrades frequently going forward with 2016. Please make it easy for us to do those upgrades. We need to be able to do an in-place upgrade of our Hyper-V clusters. So if you're running 2012 or 2, you can do something called a cluster rolling upgrade to 2016 and going forward. If you're on 2012, you're going to have to get yourself to 2012 or 2 first. If you're on 2008 or 2, you might as well just plan for a migration of some sort to get yourself to 2016. When you're on 2012 or 2, the process is pick a host, drain out the virtual machines and evict it from the cluster, and rebuild that host with 2016 and add it into the existing cluster. So you're going to have mixed level cluster. You're going to have nodes running 2016 and 2012 or 2. The virtual machines are running a VM version of 2012 or 2. So they only expect to find 2012 or 2 functionality, and that's all the 2016 hosts will give them. You're still going to be able to live migrate and fail over across the different versions of hosts. Very cool. Kind of similar to what we do in an Active Directory upgrade scenario. You do this process all the way through each of the nodes. And eventually, you're at a point where all your nodes in the cluster are running 2016. And you upgrade the functional level, one PowerShell command. And you want to get to that point as quickly as possible. Microsoft don't want you waiting months to do this. They want you to do this in a few weeks or something. And then that reveals all the 2016 functionality in the cluster, and for the virtual machines to take advantage of that, you upgrade the VM versions of the virtual machines. And again, that's one commandlet, upgrade VM version, I think, off the top of my head, and you can target one or all your VMs at one time with that. So, I don't know how long I've gone on for. I suspect it's an hour. Cool. Considering I didn't get a chance to rehearse at all, the timing's worked out well. We are continuing to do more stuff, so on September 22nd, I need to take a break because I need to write some Azure training materials and talk to customers and stuff. We are going to be doing another webinar, this time on failover clustering and storage. So some of the stuff that I've hinted at today, we'll look at a lot more in that session, and I'll hopefully have some cool demos as well when I rebuild my lab. completely. The registration page is online right now on learn.mwh.ie, and the URL is there. If you are interested in data on hardware or hypergrid, or interested in reselling Skykick at lower rates than you'll get directly from Skykick, talk to MicroWarehouse at mwh.ie. If you want to know more about our events, go to learn.mwh.ie. And if there's any questions, I shall give them a go now. Let me see if I can pop out that without kicking myself out. Thanks, Charbel. Manfred, is it possible to do a stretch scale-out file server in 2016? What are the requirements? Yes, the requirements will be that you will be running Data Center Edition and you can use Storage Replica. A lot of great blog posts and presentations out there by Ned Pyle, who's the Senior Program Manager in Storage, who's responsible for that feature. Just watch out for the gorilla animations and you can't miss them. Windows 8 AU should read Windows 10 AU. Yes, Robert, if my slides did say Windows 8 for nested virtualization, it should have said Windows 10. There's a couple of people with the Inception, Christopher and Robert. Yeah, I'm really bad at movie names, and I don't think I've actually watched the movie myself. I saw the end of it when I was channel hopping. What permissions are required for PS Direct? For PS Direct, you need to be able to get onto the host, but you also need credentials fill in to get into the guest OS as well. So just getting onto the host is not enough. You need credentials in the guest OS to do PowerShell Direct. Do you know if dedupe is planned will actually come to REFS in the future? Dedupe, basically what's supported hasn't really changed. It's still NTFS only. REFS, they've heard the feedback. I think it's one of those things they want to do. Right now, the support for dedupe is limited in Hyper-V World to just personal VDI virtual machines, not even pooled VDI virtual machines. Torsten is asking if you can use REFS in scale-out file server. Yes. In fact, in Storage Spaces Direct, you are pretty much in the REFS world. Charbel, is it possible to get a follow-up email when they're recording a webinar? Do we do follow-up emails, John?
Yes, of course.
We do.
You send out an email once we have it uploaded.
Okay, so there will be an email once the thing is uploaded, which usually is up to a week, depending. Early next week, John is saying. In case you don't know, John is our senior marketing person here and produces this along with me. Any chance of being able to do snapshots of a file server clustered share in 2016, Jeff? I don't think so, Jeff. I don't think so. Edward is asking, are more resources available to nested virtualization? I don't quite understand the question, Edward. So if you have a follow-up on that, post it. And thank you to Roland and Charbel. In case you don't know, Charbel Nemnom. I hope I'm pronouncing your surname right, Charbel, because I've never actually said it before. I've only ever read it on blogs, and Twitter and stuff. In case you don't know, folks, Charbel's another Hyper-V MVP like myself and has done a lot of great stuff. He did some stuff on Storage Spaces Direct that's great reading. And when you have the owner of that feature, Klaus Jorgensen, tweeting about your posts, you know they've got to be good. So have a look out for those. Like to use an education program or training. So Edward, yeah, nested virtualization, if you're interested in using that in education or training, superb scenarios. So if you want to teach people how to be IT pros, you know, you give the one decent machine with a fast disk, plenty of RAM, nested virtualization is going to be superb for those people. Education world, your licensing is dirt cheap, unless you're in professional training. Then you know you're looking at Windows 10 Pro or Enterprise Edition, enable client Hyper-V, and then start deploying the licenses within virtual machines and then do your nested virtualization. You're going to be able to do some very fancy stuff. You'll be able to do scale-out file server, storage spaces direct, iSCSI targets, Hyper-V clusters, the whole thing. It's only when you have hardware dependencies like direct device assignment or the use of physical TPM2 or stuff like that, you're going to have restrictions. But for the most part, you're going to be able to do 95, 99% of everything that I've talked about today. Disks and hyperconverged nodes, do they all need to be the same size? From Jeff Bailey. I don't think so, Jeff, but it would be recommended that the nodes would be identical. In fact, I think Microsoft would prefer that you keep things identical and that you don't go completely DIY with this stuff, that you will buy machines that are designed for it so you get the best possible experience. What is the hardware required for storage spaces direct, or S2D, from Stephen? What you're going to see, Stephen, is a number of the vendors out there. There's 7 that are publicly talked about. DataOn's another one that have announced their intentions. So the usual guys. You're typically looking at, normally it's 2U servers. The DataOn have a 1U option. I think Dell had a 1U option that I saw at Ignite last year. But there's specific machines that the OEMs are releasing with 2016 specifically for storage spaces direct, and my advice will be go with those. In terms of networking, you're really going to want fast networking, 10 gig minimum, and you will be strongly encouraged to use NICs that support RDMA. I would be saying to you, get ConnectX NICs from Mellanox. When it comes to networking, Mellanox do it best in the Microsoft world, and steer clear of Broadcom chipsets, which pretty much drives you away from everyone except Mellanox. And absolutely avoid Emulx like they have the plague, herpes, and everything else mashed together. Emulx, their NICs are disastrous, and the way they treated customers in the 2012 or 2 era was shocking. So if you work for Emulx, that's what you get for ignoring your customers' complaints for 9 months. Yeah, watch out for very specific announcements for storage spaces direct hardware. Stephen, again, is it possible to lab up S2D using commodity hardware? In fact, Stephen, you can lab up S2D using virtual machines. And I believe Michael Ruffley, who is speaking today at System Center Universe in Berlin, has a script that you can find on, I can never remember the name of that site. If you do a search for storage spaces direct virtual machine demo, you will find Michael Ruffley's script that will actually deploy this as virtual machines. If you have commodity hardware, you're going to need 4 servers. You're going to need plenty of disks in each machine, and ideally, if you want to do the full thing, you're going to need flash and disks inside the servers. And if you want to do it the way that it's going to be done realistically with the stuff that comes out in October and later, you're looking at using NVMe, SATA flash, SATA HDD. And realistically, the stuff isn't there, but the virtual machine option gives you a way to learn how to set the stuff up. And there's even ways of mocking SSDs and stuff like that that Michael has in his script. It's a cool script. Personally, I didn't run the script myself when I was setting it up. I had a look at what he was doing. I was like, okay, that's kind of cool, because it was just too time consuming to change names and stuff the way he'd written the script. But if you go through it, you'll learn quite a bit from the script itself. And you'll also find there's plenty of posts out there on how to deploy it from Microsoft people as well. Definitely check out Klaus Jorgensen's Twitter feed. You'll see links to his own posts on the Microsoft site on how to set this stuff up as the product has evolved during the different technical previews. And of course, Charbel's posts, because he's done plenty on this stuff too. And I think that is the last of the questions. So we'll wrap things up. Thank you everyone for tuning in. It's been fantastic to see how many people registered and tuned in for this one. And make sure you register and importantly join us for the next session on Windows Server 2016 failover clustering and storage, and more demos. I must be crazy. Thank you very much. Bye.